Hi there, I'm Kareel, one of the presenters in this video. Today, let's talk about object-oriented programming. Now that term sounds like a mouthful and seems complicated, am I right? Well, don't get too intimidated. It's actually quite simple. Object-oriented programming is a paradigm or model designed to bring together data and its behavior into a single unit referred to as an object. With the use of objects in OOP, complex systems and real-world examples can be broken down and simplified into smaller components. For programmers, this model is vital in the efficient and productive development of a program. It provides better organization, readability, flexibility, maintenance, data protection, and opportunities to reuse code without being redundant. In this video, we will be exploring classes, objects, inheritance, encapsulation, and polymorphism in the context of OOP.
Hi, I'm Kent. But before we dive into OOP, let's quickly touch on its predecessor, procedural programming. Think of procedural programming like playing a classic video game. You go level by level, facing challenges in a specific order. It's step by step, using what we call functions to get things done. In OOP, we have something similar, but they're called methods. Now, procedural programming is simpler but less flexible. Adding new features or making changes often means revising the whole program. It's also generally less secure and doesn't support code reusing features like inheritance, which we'll discuss later. So, is one approach better than the other? Not necessarily. It all depends on the task at hand, but that's a story for another video. Now back to Kirill to dig into OOP.
Now back to OOP. Let's discuss classes and objects. In OOP, a class is the blueprint for creating objects. It acts as a template that holds the different attributes, also known as the qualities of an object, and its different methods, also known as procedures or behaviors corresponding to that object. Now we've already briefly introduced you to objects, but to expound on it more, objects are the basic building blocks of a program in OOP. An object is an instance of a class and is defined to have a set of specific data variables based on the template from its associated class. Okay, I hope you didn't get lost there. Let's try to compare these terms to something more sweet and simple. Chocolate. Chocolatiers make chocolate bars by pouring tempered chocolate into chocolate molds and letting them cool. Visualize a chocolate mold as a class in OOP. It serves as the blueprint for the chocolate bars, and each individual chocolate bar made from that mold is a unique object in OOP. Each chocolate bar could have different flavors, fillings, or designs, but they all share the same structure of the mold. In the same way, an object in an OOP program shares the same structure with other objects from the same class, even if they are set to different specific values or data. Let's go and apply this into actual code. First, we make a blueprint by defining a new class using the class keyword. Then, we define and initialize attributes for objects in this class. For this, we need to use the init method. This special method is called the constructor. It gets called when you create a new object from the class. The self parameter refers to the instance of the class and is automatically passed when calling this method. In our example, each province object will have a name attribute and a capital attribute. Next, let's define a method for this class by typing out a new behavior after the def keyword. In this case, we define a method displayInfo that prints the province's name and capital. Again, self refers to the object calling this method. Now, we will create objects for our main program. Note that the province class serves as a blueprint for creating province objects. The variables you see in the brackets correspond to the attributes we had previously initialized for this class. After creating our projects, we can now use the method we defined earlier. We do this by typing out the displayInfo method after the objects we created. This will then print their attribute information on the terminal. Keep this in mind. Classes and objects are the cornerstones of OOP. Without them, it would be difficult to dig deeper into more intricate concepts in this paradigm. Classes and objects are the foundations to developing a program that is organized, modular, and reusable. They also aid developers in representing real life entities or data in their programs, as we have previously done. Alright, we've gone through the cornerstones of OOP. We will now look over its three pillars or principles, which are inheritance, encapsulation, and polymorphism. The stage is yours, Ken.
Thanks, girl. Now, let's look at the first pillar known as inheritance. This core concept deals with laying out parent and child classes in your program. So, first, a child class will inherit all the attributes and methods of its parent class, thus the name inheritance. It can also add on new attributes and methods of its own aside from those of its parent. To put it simply, it's like Filipino family surnames being passed down through generations. Take, for example, Flores, a common family surname like this, carry with them a certain reputation that is passed down from generation to generation, much like how subclasses inherit attributes from parent classes. Moreover, newer generations of the Flores family could also add on a newer standing to their family name's reputation. Moving on, we will now apply this by resuming our previous code. In this example, the tourist spot class will inherit from the province class, making tourist spot a child class and a province a parent class. This is indicated by the parenthesis province. For the child class to inherit the blueprint of the parent class, we also have to use this line of code, which calls the constructor of the parent class province to initialize the inherited attributes name and capital. With this, the child class also inherits the method from its parent, which we'll demonstrate in a few more steps. Now, let's add a new method, which is display underscore tourist underscore spot to this child class that is not present in the parent class. This will print the sentence shown. Just like what we did with the province class, we create an object of the tourist spot class and call its methods. As you can see in this terminal, through inheritance, the object can use methods from both the parent and child classes. In summary, inheritance allows tourist spot to inherit all the attributes and methods from province, and it also let us add a new functionality specific to tourist spot. Now that you know this, let's answer the question why? Why use inheritance? The primary purpose of inheritance is to reuse code from existing classes, saving us invaluable time and resources. You no longer need to define all the different attributes and methods all over again, except for initializing the inheritance. Moreover, this principle allows for a more structured and interconnected classes. When we create a new class, it's like adding a new branch to the family tree. The new class inherits all the data and implementation details from its parent or base class. This creates a coherent and logical structure that's easy to navigate and extend. Now let's move on to encapsulation to be covered by Kirill.
Now let's take a look into the second pillar known as encapsulation. By this principle, developers can choose to hide specific data and implement access control in their program. Users of the program who are not given authorized access to encapsulate the data will not be able to acquire or change its contents. Let's exemplify this core concept. Think of a securely packaged balikbayan box, the Filipino version of a care package. Notice how only the sender and receiver knows its contents and have access to them. Before sending the package, the sender, representing the developer in OOP, will disclose the contents of the box to authorized personnel of the cargo company, who decides whether or not the box contents must be changed based on cargo regulations. These cargo personnel represent users who are given authorized access. Once the package is shipped, unauthorized persons will not be able to know or change what is inside it. We will now apply this by revising our previous code for the province class. In Python, encapsulation is often implemented by making an attribute protected by prefixing its name with an underscore. This is more of a convention than a strict rule. Let's change the province class, which previously had a public attribute self.capital, and replace it with a private attribute self._capital. Even though underscore capital is a protected attribute and cannot be changed using public methods, we can still change its value within the class using private methods. The update underscore capital method allows us to safely update the value of underscore capital. Here's another revised method. This is similar to the display info method we discussed before in the context of classes and objects, although it is now a private method instead of a public one since it calls on a private attribute. It still prints out the province's name and capital. Creating an object and calling methods are actions we discussed before. Here, we create an object Davao of the revised province class and call the new private methods. Now we know that encapsulation in OOP keeps data from being accidentally changed. But encapsulation isn't just about keeping data safe. It's about smart design that provides a smoother user experience without exposing any back-end complexities. It also ensures the flexibility of the code through proper code organization. Because of this, encapsulation also improves code readability and maintainability. Since each part of the code is neatly encapsulated, making changes in one area won't create a domino effect that disrupts other parts. This is a key advantage in larger, more complex projects. I'm handing off to Kent. What's next?
Last but not the least, we'll be exploring polymorphism, the third pillar. Polymorphism is a feature in OOP that allows a single method to perform different operations corresponding to the class to which the object belongs to. This allows the object to assume various forms in a program. Take for example a jeepney, a popular mode of transportation in the Philippines. Jeepneys are quite versatile as they can serve as a daily commute vehicle, a school bus, a delivery truck, or even a mobile karaoke unit. Nonetheless, irrespective of the specific purposes they serve, all jeepneys transport people or things. Now for the application. Let's add another class to our code example. We'll now define a new class named Beach. This class is not inheriting from any other class and has its own constructor and method. Next, we define a method named displayTouristSpot in the Beach class. This method has the same name as a method in the TouristSpot class, which we discuss under inheritance. Remember, polymorphism allows us to treat objects of different classes as if they are objects of the same type. Here, we define a function displaySpot that takes an object as an argument and calls the displayTouristSpot method on it. Now, for our main program, we create objects of both TouristSpot and Beach classes and pass them to the displaySpot function. The correct displayTouristSpot method is called for each object, demonstrating polymorphism. This way, the same function displaySpot can operate on objects of different types, Beach and TouristSpot, which is the essence of polymorphism. In essence, polymorphism is essential for code reusability, flexibility, and extensibility. As we've observed from our example, you can effortlessly and repeatedly reuse the same method, different classes, and have various executions on objects throughout your program. This saves you a lot of time and keeps you efficient in the development stage of your program. On top of that, polymorphism makes debugging easier. It allows for a structure where errors are simpler to track down, making our lives as developers more manageable. But yeah, that's it from me.
Well, that's a wrap. We hope this video has given you a fun learning experience and better understanding of object-oriented programming and its fundamentals. Jolly coding!